Hello everyone, welcome to today's class. The topic that I'm going to show today is operators and expressions part 2. So the first topic that we are going to see today is the increment and decrement operators. So C programming language usually supports two useful operators. The first one is the increment and the next one is the decrement. So the increment stands for the plus plus symbol and the decrement stands for the minus minus symbol. So what does increment mean? Incrementing means adding 1, okay, in C language. So here, how can we add 1 to the variable I? We can add 1 by using this statement, which is I equals to I plus 1, okay? Or we can use the compound assignment that we have learned in our previous class, which is I plus equals to 1. So by using these two statements, we can increment the value of I by 1. But if we want to use another approach, we can use the increment operator, which is the I plus plus or the plus plus I. Okay. So using this operator, what we can do is we can add 1 to the operand. Okay. So we can add 1 to I. So this is another approach of incrementing the value of any variables. Okay. Then similarly for decrementing, if we want to subtract 1, we can do this by the two approaches that I have shown you earlier, that is the I equals to I minus 1, which will decrement the value of I by 1. And also you can use the compound assignment, which is minus equals to 1, right? I minus equals to 1, which will also decrement the value of I by 1. So these two statements are analogous. But if you want to use another approach by using the decrement operator, you can use the minus minus operator. Okay. So as you can see, this minus minus operators, they are either postfix or prefix. Okay, not for only minus minus, for plus plus. So for increment and decrement, this can be used as our postfix, that is after the operand, okay, or prefix, that is before the operand. So plus plus and minus minus can be either postfix or prefix. But what you need to keep in mind is the precedence of postfix operator, okay, is higher than that of the prefix operators. Okay, now let us see how the postfix and the prefix operator works. Okay, so here you can see we have the prefix operator plus plus I, and this plus plus I will be incremented immediately. Okay, so I will be incremented immediately if you use plus plus before, right? So for prefix, I is incremented by 1 immediately. But for postfix increment or decrement operator, what is happening is we use the old value of I, but increment the value of I later on. So how much later do we increment the value of I? So C doesn't specify how much later. At least before the next statement is executed, then the value of I is incremented by 1. So let us see what I am saying from this example. Let us assume that the value of I is 1. Okay. Now we are wanting to print the value of I, but similarly at the same time of printing we are using the prefix decrement operator. Okay, so we know for prefix decrement operator the I is incremented or decremented immediately. So here what will it be printing? The value of I, the value of I will be printed as 0, since this is done immediately. Okay, for prefix. Again, if we want to print the value of I, it will again print 0. But if we use postfix operator here, what will happen? Say we are reassigning the value of I to 1 again. Okay, so I is now again 1. Now we want to print the value of I, but what we are doing here, we are using the postfix decrement operator here, right? So minus minus is used after the operand, which is the postfix. Now if I want to print this value here, I will print 1, since for postfix we are using the old value of I, which is 1. Okay, but before the next statement is executed, the value of I, okay, the value of I is incremented or decremented. So in this statement, if we want to print I, the value of I will be printed as 0. Okay, so for prefix, what we get for prefix, the value of I is incremented or decremented immediately when this statement is executed. Okay, but for postfix, the value of I for any decrement or increment operator, that value is not incremented or decremented immediately, at least for that statement. But before going to the next statement or before executing the next statement, the value of I will be incremented or decremented. So that is why in this statement, when we decremented the value of I using the postfix operator, which is I minus minus, it will print I equals to 1, which is the old value of I. But when we are going to the next statement and we are printing the value of I, okay, then before going to this statement, the value this I minus minus will be executed, okay, and it will be 0. So you need to keep in mind which operator that you will be using so that there is no confusion. So it is better to use the prefix operator if you want to immediately increment or decrement the value of any variable, or say if you don't need to increment or decrement the value of any variable in that time, then you can use the postfix as well. But you need to be careful when using them. Moving on to the conditional operators. So the conditional operator is also known as a ternary operator. Okay. The conditional statements are the decision-making statements which depends upon the output of the expression. So it is represented by two symbols, which is the question mark symbol, okay, and the semicolon symbol. So as conditional operators works on three operands, it is also known as a ternary operator. That is why the conditional operator is known as the ternary operator. So the syntax, as you can see, is we will give the expression first, then it will be followed by a question mark, then we will give the expression 2, that will be separated by a semicolon here, and then we will give the expression 3. So let us see in this diagram how actually this is done. So firstly, we will be having the variable equals to the expression 1. So this is the decision making statement, right? So from this decision making statement, it will be followed by a question mark. Now in this decision making statement, if this decision is true, it will go to the expression 2, okay, and it will store the value of expression 2 into this variable, okay. But if this expression 1 is false, okay, then this will go, as you can see, to the expression 3, and this expression 3, the value of expression 3 will be the resultant value of this variable, okay. So here I have shown an example. So I have declared three variables, m, n, and r, and I have assigned the values m equals to 3 and n equals to 6. Now in this conditional operator, say this one, what is the decision making statement that I have? I have is m greater than n, okay. So m is 3 and n is 6, so 3 is not greater than 6, right? So since it is not greater than 6, so this statement will be activated, this n will be activated, right, according to this diagram. And if this was true, then m would have been activated, right? So this, since this statement is not true, the expression 3 will be activated, okay, and the value of this expression 3 will be stored in r, right? So let me erase this. So what will be the value of r? The value of r will be 6, since the value of n is 6 as well, okay. So the value of r is 6. Now moving on to the bitwise operators. So these operators allow manipulation of data at the bit level, okay. It converts the variables into binary format and performs bit by bit operations. So here I have declared two variables, a equals to 3 and b equals to 1. Okay. Now what are these bitwise operators? So before going into this example, we need to first know what are these bitwise operators. So as you can see, for the logical operators, we have used the and the or operators. But for the bitwise operators, we will be using a single and, single or operator, okay, and this is also known as the XOR operator, okay. We will be coming into this too later on, but let us see how this three works in our C program. So here let us take two variables x and y, okay, and these two variables can either be 0 or 1. So if uh, similar to our logical AND operation, if you use x and y here, so if x and y, either one of them is 0, the result will be 0 here, and if both of them are 1, then the output will be 1. Similarly, for your OR operation, what will be happening is if either one of this x or y is 1, the result will be 1, and if both of them are 0, then the result will be 0. And for this operator, which is the XOR operation, okay, so this is the XOR operation, and for this XOR operation, what happens is if any of these two values, okay, if x and y, if both of them are the same value, then the result will be 0, okay. So if it is 0 and 0, the result will be 0, okay. and here it should be 1. Okay, so if this value is 1 and 1, then the result will be 0 as well. Okay, now what we can see is that if the values are different, x and y's are different, 0 and 1, 1 and 0, then the values are 1. So this is the XOR operation. Now let us see this example that I was saying previously. So a is equals to 3 and b equals to 1, right? Now you can also ask, how is this AND different from the logical AND operation? How is this bitwise different from the logical operation? So we will be seeing how it is different. Okay, so this bitwise operator, they perform bit by bit operation. So as you can see, a is equals to 3 and b equals to 1. So if we convert this 3 into binary format, into 8-bit representation of binary, we have 4 zeros, 0 0 1 1. So this is the binary representation of 3. Okay, and the binary representation of b equals to 1 is this. Okay, and the end we have a 1. So now if we want to use this operator, AND operator, and we want to do A and B, what is the result that we will be getting? So you can see that this operator, when we use this AND, our program will convert this A and B into their corresponding binary formats. Okay, see, they are converted into their corresponding binary formats, and after they're converted, what happens is there will be a bit by bit operation. Okay, so this bit and this bit will be operating. Okay, and what operation will they be doing? They will be doing the AND operation. So that is why these operators allow manipulation of data at the bit level. Okay, so here what happens is the 1 and 1 for AND operation. So the 1 and 1 for AND operation is 1, so here will be a 1, and the 1 and 0 for the AND operation, 1 and 0 for the AND operation is 0, so here it will be a 0, and all of the rest will be zeros. If we have only 1 0 in our AND operation, then the result will be 0. So this A and B, that is 3 3 then and 1, will give us the result 1. Okay, which is this one. Okay, so this performs the bitwise AND operation. Similarly, for our OR operation, it will perform bitwise OR operation. So how have we gotten the result 3 or 1 is 3? From here you can see if the bitwise OR between 1 and 1 is 1. Similarly, the bitwise OR of 1 and 0 is, here it should be 1 as well if we are doing OR operation, right? Okay, and all of the rest are zeros and zeros, so this will be also zeros up to the 6th bit, right? So the first 2 bit will be 1 and 1 for our logical OR operation, and if we convert it into the decimal part, okay, this then it will be converted to 3. So that is what is happening in our bitwise OR and AND operation. Similarly, for our XOR operation, here the 1 and 1, okay, if we are doing the XOR operation for this 2, okay, this 2, then what will happen is the 1 and 1, the 1 and 1 will give us 0. So it will be 0 here, right? But the 1 and 0 will give us 1, right? And after this, all of them are zeros, zeros, so it will be filled with zeros. So we will be having the result 1 and 0 here. So this 1 and 0, if converted to decimal, okay, it will be 2. So that is why if we do A XOR B, that is 3 XOR 1, we will get 2 here because it performs bitwise XOR operation. Now this is the known as the right shift operator. This is known as the left shift operator. This is the right shift operator. 2 greater than symbols, okay, and 2 less than symbols are known as the left shift operator. So 3 right shift operator 1 will give us 1, and 3 left shift operator 1 will give us 6. So how is this done? Let us see this. So here you can see for the right shift operator, my value of A is 3 and B is 1. So if I convert this to binary format, I will be getting this, right? And if I convert this into binary format, then it will be this, right? So now what happens is, if I use the right shift operator, which is A, 2 greater than symbols B, so here A is my left operand and B is my right operand. Whatever result will be calculated, it will be stored in A again. Okay, so what does this mean? It means that the left operand's value A is moved right by the number of bits specified by the right operand B. So it means that this value, this A, okay, will be moved to the right position by the number of bits that is specified by B. Okay, so in B, what we have 1, right? So this A will be shifted to the right by 1 position. So as you can see here, we have this A, right? And in this A, this first bit will be moved to the right position by 1 position. This will also move to the right position by 1. Okay, so here the second bit will be moved to the first bit, the third bit will move to the second bit, and in this manner the eighth bit will be moved to the seventh bit. So the eighth bit is empty now. So what will be in this eighth bit? Yes, this in this 8 bit it will be replaced by a 0 as well. So as you can see from this right shift operator, this one, as it is moving from its first bit position, it is now being discarded. Okay, so the value that we get is this one. Okay, so the right shift operator is basically telling us to move the bits to the number of bits that is specified by the right operand B. Okay, so at the end the result that we will be having is 1. Now moving on to the left shift operator, say we have A equals to 3 and B equals to 1, similarly to this example. Now this is similar to the right shift operator, except instead of moving right, it will move the number of bits of this operand, the left operand, to the left, okay, by the number of bits specified by the right operand B. So here you can see that here the A will be moved to the left position. Okay, the bits will be individually moved to the left position by the number of bits specified by B. So here the number of bits specified by B is 1, right? So here what will happen is this position, this bit, okay, will move to the left by 1 position. Okay, so here this one will come to this one, this second bit position. Again, this second bit will move to the third bit. This third bit will move to the fourth bit, and so on, right? So what happens? The first bit position is now empty. So in this first bit position, it will be replaced by a 0. So as you can see, if any position after the right shift or left shift operator is empty, then that will be replaced by zeros. Okay. So here, after you move this one to this position and this one to this position, you can see they are moved to this position, and in that empty position, a 0 has been replaced, right? So this value, if converted to decimal, will give us 6. That is why the 3 left shift operator 1 will give us 6 here. So we have some special operators besides the operators that we have discussed. The first is the comma operator. The next is the size of operator. Afterwards, we have the pointers operator, which are the and symbol and the star symbol. So we'll get to know about this later on. And then lastly, we have the member selection operators, which is the dot and the forward symbol. So these operators are our special operators, and we will get to know them in our later on classes. Okay. So moving on to the next topic, which is the overall operator precedence, you can see that the overall operator precedence is given in this table. So firstly, we have the postfix. So this precedence is of the highest. Then it follows, okay, and this is the lowest precedence. So in the highest precedence, you have the postfix. So in this postfix, you have the brackets, okay, you have the member selection operators, and the most important is the increment and decrement postfix operators. Then we have the unary. So in the unary, we have the unary plus, minus, which are important ones to know. Okay, then we have the not operator, logical not operator, and then we have the prefix, the increment and decrement operators. So these are important to know, okay, so that you can evaluate your expressions. Then we have the multiplicative, which is the multiplication, division, and the mod. Then we have the additive, which is the addition and subtraction. So one thing you need to understand is the associativity as well. So in unary, you know the associativity is from right to left, right? So keep this in mind while evaluating expressions. Then after additive, we have the shift operation. Okay, this is the left shift and this is the right shift. After this, we have the relational operators. Okay, that is the less than, equals to. Then we have the equality operators, which are the equals, equal, and the not equals to. Okay, so all of this that I'm saying besides the unary are left to right associativity, right? Then we have the bitwise and bitwise XOR, bitwise OR operators. Okay, after this we have the logical and, logical OR, and the conditional operators. Okay, so as you can see, the conditional operator associativity is from right to left. Okay, then we have the assignment operator whose associativity is also from right to left. In this assignment, you can see the equals to, the plus equals to, which is the compound operators, right? Compound assignment operators. So here in the last, we see the comma, which is the special operator. Okay, so this associativity is left to right. So here in this overall operator precedence, what you have to understand is you have to know which precedence is the highest. Okay, so the ones that I have mentioned is important to understand so that you can evaluate the expressions later on. So here one thing also to observe is that the associativity. So for the unary, the conditional and the assignment, the associativity is from right to left. Now let us see how to evaluate expressions using that precedence table as well. So here I have listed some of the rules for evaluating of expressions. The first one that I've stated is using the table, we need to add parentheses to the expression that lags them. Okay, this is the first rule. Then we need to start with the operator with the highest precedence, and then we need to put parentheses around the operator and its operands. Okay, if the parenthesis is not given, if it lags them, then we need to do this. Then evaluation begins with the first parenthesized sub-expression from left to right. Okay, if parentheses are nested, the evaluation begins with the innermost sub-expression. Afterwards, this precedent rule is applied in determining the order of application of operators in evaluating sub-expressions. So you use the precedence rule in determining the order in how to basically implement or evaluate the expressions. Then we have the associativity rule, which is applied when two or more operators of the same precedence level appear in a sub-expression. So using these rules, you have to evaluate your expressions. Now let us start evaluating expressions after seeing the rules for evaluating expression and also by taking help from this precedence table, right? So here I have given expression, okay, and it has some operators here. So in order to evaluate this, we need to understand or we need to determine out of these operators which has the highest precedence. Okay, so as you can see here, we have the assignment operators here. Here is the equals to, and the plus equals to is the assignment operator. Then you have the plus plus, which is the postfix increment operator, right? Then you have the minus, that is the subtraction operator. Then you have the plus, okay, which is the addition operator, which falls under additive. So this minus and plus falls under additive. Then we have the minus minus e. So this minus minus e operator is the prefix decrement operator. Okay, then we have the forward slash. Okay, so this is our division operator, that is falls under the multiplicative category. And then we have the unary minus operator. So out of all these operators from this table, you can see that the postfix increment operator plus plus, so the C++ has the highest precedence. So after determining which operator has the highest precedence, what you need to do is you need to enclose that operand and operator within a parenthesis. So as you can see, I have enclosed this within a parenthesis, right? So this will be evaluated first. Okay, so after we have evaluated this first, which of the operator has the second highest precedence level? So you know, from after seeing all of this, you see that the minus minus and the minus here. So here the minus minus is the prefix decrement operator, right? And the unary minus and this minus minus, they fall under the same level, same precedence level. Okay, so if they fall under the same precedence level, what we have to do is we have to follow the associativity. So here for the minus minus and the unary minus, the associativity is from right to left. So we need to go from the right to left in this direction. So first what we need to do is we need to evaluate the minus f. Okay, so we need to evaluate minus f, then we need to evaluate the minus minus e. So as you can see here, first we are evaluating the minus f. Okay, the parenthesis is within a red, which determines we are evaluating this first, and the parenthesis which is colored with orange, it is evaluated second. Okay, so this is done because of the associativity. Okay, so after this, what are the remaining operators? We have the assignment operators here, we have the additive operators here, and we have the multiplicative operators. So we can see from this table that the multiplicative operator is the third precedence after the unary. So we need to evaluate this division next. Okay, so as you can see, using the parenthesis, I have to evaluate this sub expression now. Okay, so after evaluating this sub expression, the remaining operators are the additive operators, which is the minus and the plus, and the assignment operators, right? So between this additive and the assignment operators, the additive operator has the higher precedence, right? But here we can see we have minus and plus, so they fall under the same precedence level. So we need to follow the associativity here, which is from left to right. So what we need to do, we need to proceed from left to right in order to evaluate this expression with minus and plus. So here minus comes first when we are going from left to right in this direction, right? So we need to evaluate this minus first and then the plus. So as you can see, the minus that is covered with the red parenthesis is evaluated first. So this sub expression is evaluated. After this is evaluated, the plus will be then evaluated. Okay, so the plus symbol is given using this orange bracket, right? So first we evaluate the minus and then we evaluate the plus. This is simply because we are following the left to right associativity. So afterwards, what we have the assignment operators remaining, right? Only these two operators remain. And since this plus equals to and equals to also falls in the same level, we will be following the right to left associativity. So we will be going from right to left, so in this direction. That is why the b plus equals to, okay, this sub expression will be implemented first. That is why they are under the red parenthesis. Okay, after this the equals to parenthesis will be evaluated. Why is this being done like this? Because we are following the right to left associativity for the assignment operators. Okay, so this will be for all for the example 1. Now let us move on to the example 2. So in this example 2, we have to evaluate the expression where a is equals to 4. Okay, so see the expression that is given, which is b equals to a minus plus plus a. Okay, so here the minus, that is the additive minus operation is given, which is used for subtraction, and the prefix plus plus operator, that is the increment prefix operator, is given. Okay, so what we need to do first, we need to operate this first, right? So we need to put a bracket here first, right? So yes, we do that. We put a bracket here first since this precedence is higher than the minus precedence, right? Okay, afterwards what we do, we then compute the minus operator since this is remaining, right? So we then compute this. Okay, after computing this, we assign whatever value is the result here to b, right? So first what we do is we replace the value of a by 4. So this x sub expression, okay, will be evaluated first. So plus plus 4 means it will be 5, right? So this sub expression has been evaluated. Now we need to evaluate a minus this 5, right? So here when we use plus plus 4, the value of a changed from 4 to 5. So here a will now be saved as 5, right? So 5 minus 5 will give us 0. So the value of b finally comes to 0. Okay, thank you. This will be all for our part 2 lecture. Hope you have understood and enjoyed the class as well.